So firstly on the high winds and just want to talk about wind loads on houses. People get a little bit confused. So let's get into an even.
So the main things to look at are your flood hazard level, which councils define usually as the 1 in 100 year event.
Number two, there has been an observed increase in the intensity of heavy rainfall events in parts of Australia, with rainfall intensity projected to continue.
Okay, thank you, Paolo. A little bit of background on myself. I'm the CEO of the Timber Development Association. I'm a structural engineer in the background. I've been working for the timber industry for about 34 years and have done a lot of work on standards and codes, for example, the timber framing, and for my sins, the bushfire code as well. So I'm going to be talking about bushfires and high winds. And what I'm going to look there is where some of the background information first, and then look at the things you can do, which we go into the guides is about Code Plus. And what I'm looking for is a cost-effective ways to improve your resilience of your home without breaking the bank. So firstly on the high winds, and just I want to talk about wind loads on houses. People get a little bit confused. So let's get into an even playing field and understand a few things. So we report in our design standards 1684 and N1, N2s and C1s and C2s and things like that. And they relate to ultimate limit state wind speeds at meters per second. But most of us actually understand it in kilometers per hour. So you can see that, for example, a traditional N2 house at 40 meters per second is about 144 kilometers per hour wind. So that's a really large wind, but it's interesting to see how it goes up. And our Australian standards, in reference to the NCC, cover quite a large range of wind speeds from 122 to 266 kilometers per hour. So we actually got a very good design suite there. But just to understand what wind feels like, a lot of people don't understand when they think it's a windy day. In reality, it's not for a house. It's a very low. And for example, most adults will be swept off their feet at 33 meters per second, 108 kilometers an hour. Cars can start moving around at 40 meters per second, which is a traditional N2 design speed. And the current world record, Australia has it, is 408 kilometers per hour, 113 meters per second, which was recorded off in cyclone off Western Australian coast. So yes, wind is interesting in that what we feel and recognise could be a little bit different to what the house can withstand. So in improving uplift capacity and the low redundancy framing elements, there's your battens and trusses and rafters to plates. One option could be, and this is your Code Plus consideration, design for one wind region higher than designed to. So if it's designed to an N2, then make the structure an N3 resistant, and that increases capacity by about 25% and gives you a bit of resilience. Another option is to design the entire roof for the edge capacity, so that the 1200 millimeters from edge is required to have a higher uplift capacity. We'll design the entire roof, and that gives you 60 to 80% increase in capacity, and it also future-proofs for you putting PVs onto the roof at a later date, so you don't need to go and upgrade your fixings and fasteners when you put photovoltaics in. And the third option, is just changing the nail type. So if you're required to use a plain shank nail, then by just using deformed shank nail, then you're doubling the capacity of the nail. So it's a simple thing which is very cheap. To just, instead of using plain shank, just use deformed shank. And with your deformed shank as part of your design, then maybe use a screw or put an extra nail into it. So these are very simple ways of increasing your capacity and more so with the extremities area.
Thanks, Andrew. That was much more technical than mine's going to be. My name's Clyde Barpay. I'm an architect and associate at JDA Co, based in Brisbane. Thanks to Paolo for inviting us on this great project. I'll just give a brief snapshot on what JDA's background is in the flood disaster and resilience space and what learnings we've sort of brought to this guide. And towards the end, hopefully I can get through a case study that we've worked on. So just for some context, Brisbane is the most flood impacted area in Australia with almost $300 million in annualized damages and 280,000 people currently living in a floodplain. So we sort of started in 2011 in our interest in this space after the major floods. They basically showed us how unprepared our city was for major flood events. So from 2011, through Emergency Architects Australia, which is a non-profit, JDA began running pro bono building assessment programs for uninsured homeowners across 34 suburbs in Brisbane, Ipswich, and Somerset. We undertook over 250 individual assessments and assisted in community awareness that affected over 1,000 homeowners. The learnings we got out of this was seeing that damage firsthand and speaking with people directly affected by the disaster. And that was immeasurable, like the information that we learned and the impact that it had on our future research. So after 2011, we were fortunate enough to have a few private residential clients living in floodplains that we were able to take these learnings and about materials and construction systems and apply them into real projects. And through that, we've had success in lowering insurance premiums for these clients by up to 50%. So just flicking through a few of our projects. Using steel marine ply and experimenting with removable cabinetry, having flush sills with full height openings at the ends to make it easy to clean out, flush door sills. This is us experimenting with a sort of sandwich type VJ wall system. And simple things like permeable screening to help water flow through easier. Through this learning, we were able to work on a few guides with local councils and state governments. And through the state government guides, we've been able to sort of create a library of construction details for walls and floors for both new builds and retrofits. The guide also goes through identifying these risks and how they might apply to a typical raised home, or typical home, I should say. So the main things to look at are your flood hazard level, which councils define usually as the 1 in 100 year event, plus a 300 to 500 mil buffer. And then knowing that in relation to your floor level. And so everything below that, you should try and identify those risks. We also recommend prioritizing in terms of cost benefits. So utilities, floors and walls are crucial. Doors and cleanup and dry out are secondary, and cabinetry is typically the least bang for buck because you're spending a lot for a little gain. The guide goes through applying these principles with those applying these principles to a typical house on stumps. Things like, you can get sheet sizes in 1200 high, so you don't have to replace the whole wall linings when, if cost is an issue. And then house raising, which is a great benefit of timber homes that are existing timber homes on stumps. We basically recommend going higher than the council minimums because, as we saw in 2022, these council minimums change all the time and sometimes they're exceeded in real events. So when you can, just go higher.
Fantastic. Well done, Andrew and Clive. Some great insights in those presentations. Thank you. My name's James McIntosh. I'm the Senior Manager of the Cedric Building Consultancy Division, which incorporates forensic engineering, consultancy, quantity surveying, project and tender management. So let's have a look at some ICA data, the 2022-2023 period. We talk about in the industry, there was 13 major events. There's 8 on your screen there that were all significant events. You can see there Cat 221, Southeast Queensland, New South Wales flooding was a $6 billion event, both across personal lines, which are personal lines of insurance, which is your consumer, your typical homeowner properties, and then there's the commercial as well. So right across both sectors, significant events nonetheless. So it's a significant amount of capital that these insurers are paying time and time again. Thank you, Paolo. So I want to focus on a document that was produced in 2022, which I thought was a good one in terms of flood by the Insurance Council of Australia. It talks about climate change and the flooding and future risk. Now, I think there was 6 or 8 top takeaways out of this inquiry. I want to focus here on 4 of them, the top 4. You'll see there, number 1, flooding from river flooding and high intensity rainfall is one of the costliest extreme events in Australia. Number 2, there has been an observed increase in the intensity of heavy rainfall events in parts of Australia, with rainfall intensity projected to continue. Number 3, modern day land use planning settings and associated building controls do not adequately protect property from flood risk. So I want to focus on those 3 and the fact that they are all indicating the risk of flood is increasing. Therefore, the risk of communities being affected, insurance companies being affected in terms of how they can continue to provide value for money policies are all increasing in terms of their risk. Number 4, the current building code does not consider building resilience to flood risk. That's about regulation and reform. So we've got 3 major takeaways, the top takeaways, if you like, telling us that this is not declining. This is a problem that is going to continue to increase. And we've got some challenges around regulation and reform as it relates to flood resilience. Thank you, Paola.